Here we have a problem on derivative, and we have to give the domain of the derivative. So here we have a piecewise function. To find the derivative of a piecewise function, we have to find the derivative of each piece separately. Okay, let me do it. So the derivative of f of x is just f prime of x. And to get the derivative of x cube, you can use the power rule. That is, we have to bring this exponent in front of the variable and subtract 1 from the exponent. Then I'll be getting 3x square if x less than or equal to 0. And now I have to get the derivative of this 2x. To get the derivative of this 2x, here actually 2 is a constant multiplied by the variable. When I find derivative, if there is a constant multiplied by the variable, I have to keep the constant as it is. So let me keep the constant 2 as it is. I have to get the derivative of this x with respect to x. So because here it's a function of x, so when I find derivative of this function, I have to find derivative with respect to x. So the derivative of x with respect to x is just 1. So 2 times 1 is 2. So the derivative of this second piece 2x is just 2 if x greater than 0. Okay, now I got the derivative of the given piecewise function, that is f prime of x equals to 3x square if x less than or equal to 0, and f prime of x equals to 2 if x is greater than 0. Okay, I have to answer one more question, that is I have to find the domain of the derivative. Okay, so once I get the derivative of a piecewise function and I want to find the domain, I just have to check so whether the derivative of the first piece is defined for all the values of x with this condition x less than or equal to 0. Yes, 3x square is defined for all the values of x in this interval x less than or equal to 0. And also the second piece, that is the second piece of the derivative 2 is defined for all the values of x in this interval x greater than 0. For any value, if I plug in any value where x is greater than 0, it is different because it's a finite value, it's a constant. The same thing for the first piece. So for any value, if I plug in any value for x, where x is less than or equal to 0, this 3x square is defined. Okay, and apart from that, whenever we have piecewise function like this, so apart from the stuff we have checked so far, we have to check so whether the derivative is defined for this particular value over here. This is a transition value, so we have to check whether f prime of x is defined. So for this value, so for that, what I need to do is I have to check the left side limit and right side limit of 0 because it's a piecewise function. Okay, first let me take the left side limit of 0 for f prime of x. So limit x tends to 0 negative f prime of x. So here there is a negative sign on the right side top corner of 0. It indicates that is x approaches 0 from its left side. That is it's a left side limit of 0. Okay, so when x approaches 0 from its left side, all the values of x over here are less than 0. Then we have this condition. Okay, then what stuff do we have to take for f prime of x? When x is less than or equal to 0, we have 3x square for f prime of x. So we can plug in this 3x square for this f prime of x over here. So limit x tends to 0 negative 3x square. The next step, that's all. This negative sign has nothing to do with the calculation part anymore. Okay, now we can plug in 0 for x into this function. Then I'll be getting 3 times 0 square. So 0 square is 0, 0 multiplied by 3 is 0. So the left side limit of 0 for the first derivative f prime of x is 0. Now, let's find the right side limit for the f prime of x at x is equal to 0. So limit x tends to 0 plus. So this positive sign indicates right side limit, that is x approaches 0 from its right side. Okay, so limit x tends to 0 plus. This time x approaches 0 from its right side. When x approaches 0 from its right side, all the values of x over here are positive. Then we have this condition, x greater than 0. So when x is greater than 0, so what stuff do we have for f prime of x? That's just 2. So for f prime of x, we have to plug in 2. So now I have to plug in the limit 0 for x over here, but I don't find x here. So the result of this limit is just 2. Okay, now I got the left side limit and right side limit of 0 for f prime of x. So the left side limit of 0 is just 0. The right side limit of 0 is 2 for f prime of x. So the left side limit and right side limit are not equal. So the first derivative, I mean f prime of x, is undefined at x is equal to 0. So for all real values of x, f prime of x is defined. So the domain of f prime of x equals to all real values except 0, because at x is equal to 0, f prime of x is undefined. The reason is, so the left side limit of f prime of x at x is equal to 0 and the right side limit of f prime of x at x is equal to 0 are not equal. So f prime of x is not defined at x is equal to 0. So we exclude 0 from the domain. So the domain of f prime of x is all real numbers except 0.